So today we are moving on to sum and difference formulas. So sometimes I'm asked to find the values of angles that aren't 30, 45, 60, or pi 6, pi 4, pi thirds. So here are the sum and difference formulas. So depending on if I'm adding two cosines together, I use the top formula. If I'm subtracting two cosines, I use the bottom. If I'm adding two sines, I use this formula. If I'm subtracting, I use this. Adding tangent, subtracting tangent. I will give you these on the test, but you need to know how to use them. Okay, so number one wants me to find the exact value of cosine 75. So what two angles that I do know how to find, 30, 45, and 60, can I either add or subtract to get 75? 40 and 35? Wow. Nope. 30 and 45 is what I meant to say. So the angles that I do know are 30, 45, and 60 from the chart. Because those are the same things as the chart I told you to memorize. The pi 6, pi 4, pi thirds one. So pi 6 is 30, pi 4 is 45, pi thirds is 60. So then I'm just looking for a combination of 30, 45, and 60 that will either add or subtract to 75. So, yep, wait, let me see that again. Yeah, that's right. Okay, so did I add or subtract those two angles? I added, so I'm going to use the top formula for cosine. So I'm going to have cosine of 30 times cosine of 45 minus sine of 30 times sine of 45. The cosines are being multiplied together and the sines are being multiplied together. Okay, so what is cosine of 30 degrees? Off the chart. 30 is the same thing as pi 6. Okay, what is cosine of 45 degrees? That is pi 4. Okay, what is sine of 30 degrees? What? Yeah, you're right, 1/2. That's pi 6. And then sine of 45? Okay, questions so far on where I got any of those numbers? Okay, so then I want to multiply my two fractions together. What's the square root of 2 times the square root of 3? Square root of 6, and 2 times 2 is 4. I have the negative in the middle, and then 1 times square root of 2. And then 2 times 2? 4. So my denominator is the same here. What can I do with those two? I can combine them into one giant fraction. So I'm going to have the square root of 6 minus the square root of 2 over 4. Because the numbers inside the radical are different, I cannot go any further, and this is my final answer. Huh? Because you can't combine numbers inside, or like when the radicals inside are different, you can't combine them. Then I could combine it. So next one is pi 12ths. So this one I am using pi thirds, pi sixths, pi fourths, and I'm either adding or subtracting to get pi 12ths. Pi 6 what? No. Because pi 6 plus pi 6 gives me pi thirds. Is 1/12 larger or smaller than 1/4, 1/3, 1/6? Smaller. So I know I'm going to have to subtract. That's okay. That's okay. Okay. So I just want to try subtracting in different combinations. One third minus 1/4? Yeah. So pi thirds minus pi fourths. And I think if you had also done pi fourths minus pi 6, it would have given you 1/12 as well. But this was the first answer I heard. So, sine. Which equation am I using? The top or bottom one for sine? Bottom. So I'm going to have, whenever I have these, my first one is my alpha and my second one is my beta. So then I'm going to have sine of pi thirds times cosine of pi fourths minus cosine of pi thirds and sine of pi fourths. Okay. So then sine of pi thirds is cosine of pi fourths, cosine of pi thirds, sine of pi fourths, okay, then I just want to multiply my fractions, so square root of 3 times square root of 2. And then 1 times the square root of 2. So then they have the same denominator, so I can put them in the same fraction. And then since they're different numbers inside the radical, I can't combine those. I know. It would have given you the same final answer, but your middle steps would have looked a little different. Any other questions on number 2? Okay. So number 3 wants me to find the value of 7 pi 12ths. So, which two angles get added here? Or subtracted? Okay, so, I forgot to write my trig function. This should say tangent. My bad. Okay, so for tangent, which one am I using, top or bottom? Top. So I'm going to have tangent of pi thirds plus tangent of pi fourths over 1 minus tangent of pi thirds times tangent of pi fourths. Okay, what is tangent of pi thirds? Radical 3. And tangent of pi fourths? Okay. On the bottom, I have 1 minus tangent of pi thirds. And tangent of pi fourths? 1. So what do you want me to do next? What do you mean combine like terms?
Oh,
Okay, what do you really want? Okay. What do you really want me to do? Nope. I can't cancel. Multiply the 1 by that square root of 3 on the bottom. Close. So we don't like the radical on the bottom. How do I rationalize when I have subtraction on the bottom? No. I multiply by the conjugate. We talked about this last semester. Yeah, it's where you change the sign in the middle. So the top and bottom both get multiplied by the conjugate. Or I literally just changed the sign in the middle. Yeah, because it was a minus and now it's a positive. I don't care about radicals on my top. Okay. So then when I multiply square root of 3 times 1, square root of 3 times square root of 3, 3. Because remember, you multiply the numbers on the inside, which gives you the square root of 9. But the square root of 9 I can't find. 1 times 1. 1 times the square root of 3. Okay. Okay, so on the denominator, 1 times 1. 1 times the positive square root of 3. Negative square root of 3 times 1. Negative square root of 3 times 1. Negative square root of 3 plus square root of 3. Negative 3. What'd you get lost? Oh. I think I meant to say positive. I do that sometimes. Okay. Yeah. So what do I get on my numerator when I combine like terms? 2 square root of 3, okay. And then what else? 4. Because I had 2 radical 3s. And then 3 plus 1 gave me the 4. And what about on my denominator? Just negative 2. The square root of 3's cancel out. Do I like the fraction as it's written?
No.
Everything can be divided by the negative 2, so I'm going to split this up into 2 fractions. I'm going to have 2 square root of 3 over negative 2 plus 4 over negative 2. So 2 square root of 3 over negative 2 gives me, or just negative square root of 3. And positive 4 divided by negative 2. And that is my final answer. Yeah, tangent is more time consuming. Yeah, so if I wrote the negative 2 first, that would have been fine. Okay, so on number 7, it wants me to find the exact value of sine of u plus v, where sine is 4/5, and sine of u is 4/5, and cosine of v is negative 12/13, and it tells me what quadrants these are in. So for my u triangle, this is in between 0 and pi halves, so that's the first quadrant. Sine is opposite over hypotenuse. This one is a 3, 4, 5 triangle, and this is triangle u. Triangle V is in between pi halves and pi. This is in the second quadrant. And then cosine is adjacent over hypotenuse. This one is a special triangle again. That gives me 5 for my y value. Then I just need to find sine of u plus v. So that one is going to be sine of u, cosine of v, plus cosine of u, sine of v. So I want to go find each of those values on those two different triangles. Sine of u was 4/5, that was given to me. Cosine of v, again, was given to me. This is negative 12/13. Then cosine of u, I want to use this triangle to find cosine, which is adjacent over hypotenuse, so 3/5. And then sine of v is this triangle over here, so that's going to be opposite over hypotenuse, which is 5/13. And then I just want to multiply these two fractions together. I don't want to simplify them because I want to add them together in the end. So I have 4 times negative 12, which gives me negative 48. 5 times 13 gives me 65. On the second fraction, 3 times 5 gives me 15. And on the bottom, I'm going to have 65 again. Then I add the two fractions together, and this gives me negative 33 over 65. I would check to see if I could simplify it, but this one doesn't simplify.